Okay, number 8, consider the function, okay, g of x is equal to a times 3 to the x. Okay, and they want to know that if a is greater than 0, what happens as g of x, what happens to g of x as a increases? Okay, well, give me a number between 4 and 12.
7.
7, okay? So let's make a 7. All right? And let's make it to the first. Okay? What's my answer? Everyone, come on, take a look. What's my answer?
21.
21, okay? So I take 7 times 3. Now, give me a number between 8 and 17.
17.
17, okay? So 17 times 3 to the first. What's 17 times 3? What is it? Somebody said it. 51, okay? So I've got 21 here, I got 51 here. What is happening to the value of g of x?
Going up.
Okay? What happens to g of x as a increases? Does it increase at a faster rate, a slower rate, decrease at a faster rate, or slower rate? Yeah, it increases at a faster rate. So, up here, okay, let me get your attention up here. Then when this is taking place, I know, okay, that that's 21. When that increases, that's 51. So it's rising quickly. All right, let's take a look at number 9. Okay. All of my papers got shuffled up here. 39, there we go. 23. Man, where'd they go? 3. 1, 2, 3, 4. There we go. Number 9. Okay. Exponents. Okay. I've got 6 x to the negative 4. Okay. Times y cubed. Okay. Taking all of that to the second power. Over 2 x to the negative 1 y cubed. Okay. Now, I goofed up here. These, okay, come all the way around. Okay, so what is happening to every single letter and every single number inside of here? What is happening to it? It's being squared. Okay, I'm taking it to the second power. All right, so let's just take every single one to the second power. All right, so I've got 6 squared. That's 36. I have x to the negative 4 times 2. X to the negative 8. I have y to the 6th. All over 2 squared, which is, everybody, 2 squared. 4. I have x to the negative 2. I have y to the 3 times 2?
6.
6. Okay, so y to the 6th. All right, just taking a look at this without looking at negative exponents, what's going to happen to my y to the 6's? They're going to cancel. Okay, those are gone. What's 13 divided by 9? Or 13 divided by 4?
36.
36 divided by 4. There we go. 36 divided by 4.
2.
No? 9. Okay, 36 divided by 4, 9. Now, what have I told you about negative exponents? Negative exponents tell you I'm in the, oh, come on, guys. I'm in the wrong place.
Move me now.
Yes, there we go. I'm in the wrong place. Move me now. So I have x squared over x to the 8th. What do I do with my exponents when the bases are the same and I'm dividing?
Add them.
Not add them, that's in multiplying. I subtract. So I have 2 up top, 8 down below. How many are going to be left down below once I cancel them out?
6.
6. So I have 9 over x to the 6th. Okay, any questions? All right. Next one. Okay, number 10. Okay, what function generates the pattern shown on the table? Okay, now, this is again one that if, okay, you prefer the plug and chug method, okay, which for some of you that's easier. For some of you, you can look at this, okay, I can do it in my head. Others, you can put this in your calculator. There's multiple ways to do it, okay? If we just take the plug and chug, all right, I have 0, 1, 2, 3, and 4. I have 1, 2, 4, 8, and 16. Now, which one, if I'm looking at, hush everyone, 2 to the x, if I'm looking at log base 2 to the x squared plus 1, and x cubed plus 1. All right, now, if I look at the first one, okay? If I look at the very first one, all of these work for the first one. Yes, okay? If I plug in 0, okay, where x is, all right? Okay, I'm sorry, it doesn't work for, it doesn't work for that, okay? But all the other ones, if I plug 0 in, it's going to work. It's when I start plugging in 1 that all of a sudden this one goes away. Oh, I'm sorry, that one still works. Okay, that one still works with 1, that one still works with 1, okay, and that works with 1. Okay, now when I start plugging in 2, 2 squared is 4, 2 squared is 4 plus 1 is 5, 2 to the third is 8 plus 1 is 9. Now I can get rid of those two. So again, if you prefer the plug and chug method, make sure you're testing every single one of those out. All right, number 11, okay. This, I prefer you to work out algebraically, okay, because you're going to have to see, okay, on the EOC, there's going to be parts, okay, that are going to be, you can't use a calculator with it. So, if I take the square root of 5x plus 6 plus 3 equals 7, okay, what's going to be my first step? I want everybody involved here. Okay, everybody involved. What's my first step? Well, subtract 3. Okay, I like the idea of combined like terms because I've got to get that over to there. Okay, so subtract 3. All right, so now I have the square root of 5x plus 6 equals 4. Now what's my next step? I have to get rid of the square root. Okay, so how do I do that? I take it to a second power. Okay, I've got to cancel out whatever number is right there. When we don't see it written, it's 2. So now I have 5x plus 6 is 16. Subtract 6, subtract 6. 5x is 10. What does x equal?
2.
2. Okay, x is 2. All right, last ones. 12, 13, and 14. All right. Now this, on number 12, okay, my car value is decreasing. Whenever I need to know, all right, whenever I need to know something is decreasing, they're going to use an exponent to find it. Okay, when it's decreasing or increasing by a percentage. Okay, usually we look at things that grow rapidly, okay, usually referring to bacteria. Okay, you would have seen this in probably Miss Horn's class, okay, or Miss Strain's. All right, where something is decreasing or decreasing in this case, the number I am taking to the exponent must be less than 1. Okay? It has to be less than 1. So, if I'm looking at less than 1, which one can I automatically cancel out? I'm looking for the percent. Okay? It's decreasing. So which one of the problems, A, B, C, or D, can I automatically cancel out? D. Okay, because the number in the middle is greater than 1. Then I take a look at, okay, I can work with A, I can work with B, work with C. Now let me tell you what each one is doing. Everybody look at number 12 right now. A, it's telling me it's decreasing, okay, by 95% a year. All right? Is it wise to drive a car that decreases at 95% a year? No, okay? That's not working. Part B, okay, it's telling me that I'm decreasing by how much? 50%. Okay, do I want to drive a car that's losing half of its value every single year?
No.
No, okay, unless you live in Alabama, then it's normal. Okay? Now, the last one, okay, it is actually telling me it's dropping by 5%, or I'm retaining, okay, 95% of my value. Now, that's not bad, okay? I'm only using 5%. So, the answer is C. Okay, number 13, there's a couple of ways that you can solve this, but here's how I would do it. And I want all eyes up here. All eyes up here so I know I have your ears. On number 13, okay, when you have a polynomial that size, whichever way you prefer, I still want you to put this in your calculator and hit graph. All right? And I want to see where it hits. Now, what if they have a problem like this, okay, on the EOC, but if they have a problem like this on the EOC, but they don't let you use a calculator, how do I solve it? So I have x cubed plus 6x squared minus 13x minus 42. Now, my possible options are 7, -7, -3, and 3, 2, and -2. Okay? Those are my possible answers. How can I set these numbers up to see which ones do not have a remainder? Okay, that may be a hint. These do not have a remainder. What can I use to find the zeros in this? Synthetic division. Okay, now they're telling me these are my actual answers. Okay, these are the actual answers. Now, what is the actual, what's the correct answer for this one? B. Okay, so it's telling me that my answers are -7, okay, a +3, and a -2. Okay? Now, what am I going to put in the box? These are my solutions. What goes in the box? What are these?
Solutions.
Solutions. So what goes in here?
The solutions.
Solutions. So let's start with -7. Now, what goes along the top row? To help you remember. 1, 6. There you go. So, bring this all down. Now, what do I do with my first number? Bring it down. Okay, so I have 1. 1 times -7. Everybody, come on.
-7.
-7.
Please pardon the interruption. Seniors, since you have some extra time this afternoon, Ms. Perry has a few scholarship opportunities in her office. One especially for if you're going to Chattanooga State next year, and 2 that are for any school you'd like to attend. Also, if you are 16 and over and want to participate in the blood drive next week, please see Ms. Perry for a application for that. Today, lunches will only